In this video, you learn importing modules in Python. This is the second part of a series. In this video, you learn the mechanics of importing. If you have missed the first part of this tutorial, click here to watch it first. Otherwise, let's go. In the first part, you have learned about built-in modules, their locations, and how importing modules allows namespacing in Python. But between the import statement and using a module, many things have happened. The tasks of the import statement are finding a module, loading it, compile it into bytecode, load in memory, and bind to a name. Let me break that down for you. For this, I will use the example from the last video. The example has a main script and calculator module. It is quite amazing what will happen once main imports calculator. Here is the process. But don't worry, I will take you through it step by step. I start with the import statement. In the previous video, I told you that Python will check if the module exists on your computer. But actually, Python takes another step before this. Python will check if the module is already loaded. Let me show you. I delete all the code. I import sys. I print the modules and execute the code. That is a lot of entries. Look at the result. It is a dictionary with loaded modules. These modules were loaded automatically at startup. As I already showed you, there is a difference between modules that are built in the interpreter, like the sys module, and modules that are loaded from a Python file. But wherever modules come from, they need to be imported to create a name for them in the local scope. So, the modules list keeps track of already loaded modules. Let me demonstrate that by importing the calculator module. Look at the last entry. The module has been added with key calculator. And by importing it, a name was created in the local scope. There is the calculator name, which serves as a namespace for the calculator module. I can check what is in the namespace. And here you see the add and subtract functions. What happens when I introduce a second module to the system? Main uses XYZ and calculator, and module XYZ also uses calculator. If the import mechanism checks for existing imports, the calculator module should only appear once in the modules list. I create module XYZ. I import calculator, and from main I import XYZ. I delete the last two print statements. Okay, what happens when I run the code? Look at the list of modules. Calculator only appears once. So, where does this bring me in this diagram? Python checks if the module is already imported. If not, Python searches and loads the module and binds it to a name in the local scope. The second time the module is imported, Python finds it in the list of modules and binds the existing import to a name in the local scope. So what happens exactly when a module is imported the first time? Have a look at this step. Python searches for the source file. If it can be found, it will be loaded. But what if it cannot be found? Let me demonstrate that. I delete everything in main and import calculator2. I run the code again. I get a ModuleNotFoundError. So now you know what happens if Python cannot find the module from the import statement. The diagram is getting more complete, but there is a piece that I ignored until now. You must be wondering how the cache folder is created and what role the Pike files play in this story. Well, this diagram is not complete yet. More things are happening. It turns out that it is not Python source code that is loaded into the interpreter. Instead, the source code is first compiled to bytecode. Yes, Python has a compiler. However, the goal of the compiler is not to create Windows, Mac OS or Linux executables. Let me explain what it does. The Python interpreter is also known as bytecode interpreter. Its input are compiled files known as code objects. An example of this is calculator.py. The compiler compiles Python source files into code objects. Loading bytecode instead of source code has an obvious benefit. The interpreter does not have to check the syntax and semantics of a code file, since this was already done by the compiler, which increases the loading speed of programs. It is interesting to know that the source file of a generated Py file always has to exist. Even if the Py file is already generated, when the source file is deleted, a ModuleNotFoundError is raised. So, the source file is found. What happens next? Python checks if bytecode is already generated. If not, the code is compiled and the Py file is created. If the Py file was already available, Python checks if the source file is newer. If the source file is newer, it is recompiled and a new Py file is created. From this point, all paths lead to loading the bytecode into memory and binding it to a name in the local scope. You probably have observed the process of creating the cache folder many times in your project, but what about built-in modules? If you navigate to the built-in modules folder, you will find a cache folder here too. And by learning that all modules are compiled to bytecode, I suddenly had a new question. When modules are compiled to bytecode, why is the main script not? Well, the main script is compiled to bytecode, but by default it is not stored as a Py file. But why is that? That is a good question, but I do not have the answer to it. If you have any idea what the rationale behind this was, write it in the comments. And that's all for this video. Thanks for watching.